let's undertake the next installment in this exciting lesson about different functions. And this one is going to be the square root of a function. So we're going to be taking a look at, we're going to be applying a mathematical operation to a function. And this time it's going to be a square root of a function. So our lessons about radical functions should definitely help us out. The square root of a function y is equal to f of x can be thought of as a transformation on the parent function y is equal to f of x, and they're mapped into the square root of the function y is equal to the square root of f of x. Probably better or easier to think about it as a transformation that follows this mapping notation. Point xy maps into point x comma the square root of f of x. Now, really, really f of x can be thought of as the square root of y. Right? That's what we're really saying here. So, believe it or not, there are many interesting things about square roots. 5 as I count them. Well, these 5, I don't know if they're interesting, but they're definitely going to help us out. So, let us talk about square roots. Now, 1. The square root of -1 or any negative number, the value does not exist in the real number set. So you can't take the square root of a negative number in the real number set, which is high school math. 2. The square root of 0 is 0. And what you'll often find on a graph, it's called a stationary point. So this is low-hanging fruit for us. We'll come to that later. The square root of x is greater than x for all x in the interval 0 to 1. In other words, the square root of a number of any number between 0 and 1 is exclusive of, the square root of a number between 0 and 1 is greater than the number itself. So, for example, a lot of people use the word decimal and it drives me crazy, but really I'm just talking a number between 0 and 1, like take, for instance, a quarter. The square root of quarter is going to be greater than 1/4 because 1/2 is greater than 1/4. And then now, here we see that lost my count in counting really interesting facts. That's 3. This is going to be 4. The square root of 1 is equal to 1. So again, on a graph, we'll notice that this is a stationary point. Really interesting, really, really important. The square root of x is less than x for all x, where x is greater than 1. So for instance, the square root of, I don't know, pick a number, 7. The square root of 7 is less than 7. And that's true for every number that is greater than 1. And in general, as our radicand increases, the square root of x also increases. Bigger the x, the bigger the square root of x. Will result in an increasing function overall. So we're going to try to apply some of these learnings of graphs into these 5 above facts. If f of x is less than 0, that is, if my y is negative on a graph, and I take the square root of that graph, the function is undefined and doesn't exist. If f of x, the parent function, now I'm really talking about x-intercepts or zeros. If f of x is equal to 0, the graph of f of x and the square root of f of x has stationary points on x-axis. So these are better known as zeros or x-intercepts. Now the graph of y is equal to the square root of x. So if the y values are between 0 and 1, the square root graph will be higher than the parent graph. And this is because the square root of f of x will be greater than f of x. When f of x is equal to 1, when the y value is equal to 1, the graphs of f of x and the square root of f of x have a stationary point. So whenever the y values is 1, there we have a stationary point. That was also true for when the y value was 0. Last but not least, the graph of y is equal to f of x is less or lower than the graph of y is equal to f of x whenever the y value is greater than 1. So maybe, just maybe, let us get a start on an example here. So I am going to calculate, what am I going to do? Maybe, just maybe, I'm going to graph this first and then this. So given these x values, let us calculate these y values. Given these x values, let's calculate these y values. I'll give us some time to fill it in. So I have calculated the y values if y were equal to 4 minus 2x. Now I'm going to simply calculate or simply take the square root of those outputs. So the square root of 12. Now you can repeat the whole process, but really what we're going to end up here is square root of 12, square root of 10, square root of 8, square root of 6, square root of 4, square root of 2, square root of 0. And really the only ones that I know for sure are this, this. And these are all approximate. So really I might use the square root of 9. I don't know what this is, maybe 3.1. Square root of 8 is less than the square root of 9, so it has to be less than 3, right? So this is going to be, I don't know, 2.8 approximate. So the green values are the approximate values. I have no idea what the square root of 6 is, so I'm just going to put, now all the approximate value, I'll put this tilde in front. So approximately 2.5, and this is going to be approximately 1.4, 1.5. So, and the square root of 12 is going to be approximately 3.5, right? Because it's in between the square root of 9, which is exactly 3, and the square root of 16, which is exactly 4. So here I have y values that I can graph. So, or let me try to think about a different way. I'm going to maybe graph this point right here. Let me take a look at this. Isn't this not a linear function where the y-intercept is 4 and we have a slope of -2? There we have it. So this is my function. I could use the table of values as I've written up, or I can apply the transformation on my graph, depending which one we are more comfortable with. Now remember, as we go from maybe the blue to the green, we go take point x, y that exist on this point, and we transform them so they become x comma, the square root of y. So really, if I want to graph this function right here, all I simply have to do is to take the square root. So the square root of the y value here is square root of 4 is 2. Yay! I have 1 point on my new graph. Now, remember our critical learning later on, or earlier. My y value here is 0. Whenever y is 0, this creates a stationary point. My y value here is 1. Right? If the y value is 1, the x value stays the same, and the y value stays the same too. The square root of 6, well, I have no idea. 2 point something, the square root of 6 has to be between 2 and 3. How does that look? Right? It's somewhere in there. Are we okay? I find it easier, instead of working off a very challenging table here in which you're trying to estimate I'm starting to get the hang of working off of a graph. So, key idea number one, the square root of something that's negative. Well, it doesn't exist. In other words, here's my f of x, and it's negative. When I do the square root of it, there's no function that exists when I take the square root function. My y value is now here too. The square root of y is going to be greater than y itself whenever my y is stuck between 0 and 1. So in this interval, it's a very short interval, I have to make sure that my square root function, I have to show it to you that it's actually higher than this regular function. And now I connect the dots, and it should have a nice sort of curve to it going on there. And I have just graphed a square root function using some simple ideas, those 5 interesting cases of a square root. Please ask questions. I know this cannot be easy.